All right. So let's talk about our first example here. The section we're in, obviously we're in the third section. Hey, no talk. So, third section, we're talking about the properties of logarithms.
Homeschooled Matt did not open my Snapchat from 6 to 9.
Okay. Hey, properties of logarithms. The three properties we have. We have a power rule, which is going to be the first one we're going to start with today. After we're done with the power rule, then we're going to do a product rule.
Didn't we do these yesterday?
Yep.
Yeah, we definitely
And we're gonna try to finish with a problem where we do like all of them at the same time.
Why would you want to do that?
The one example I did kind of mixed, I think, division with power rule.
Why?
So, all right. Now the thing is today we do need to understand how this stuff works because the next section we go into is, I would say it's probably the more difficult of this chapter that we're in because it uses this stuff. And it's very apparent for when we get to it, whether you paid attention on the easy stuff or not. So that's one thing that'll be very apparent when we get there. We're talking about quotient rule. This will be our last rule I want to cover today. I want to go through each rule. I'm going to try a problem. I'll put one on the board. I'll have you try a problem, see if you can do it correctly. Again, the problems we pick are right out of the book. And then we'll get to our last two problems that will be done early today. So, because I want to make sure that we get all the notes we need. Okay. We're good?
Yeah.
Hey, check. What this group is doing here. Check.
You, Justin, you're disrupting me.
Okay, all right. Here we go. Power rule. All right, the basic power rule that we talked about yesterday. Anytime you have a logarithm with powers and things in the power. What we talked about yesterday, this is the exact problem I think I wrote on the board yesterday.
Yep.
You are allowed to drop this power out front and it multiplies on the front of the logarithm. Okay, whatever it is. Now this, it doesn't matter which type of log it is. It could be a natural log. So it could be a problem like this. Natural log of, let's say x to the 15th. We can still drop the power out front and we can write it like this. That still works. That you can actually do that. And it just multiplies on it. So it doesn't matter the type of log. Now remember, one of the examples I talked about the other day, this is I think on Monday or Tuesday this week.
Monday it was.
If you leave the 2 off the logarithm, like you don't put the little like 2 there, it's a 10 that sits there.
What?
And a lot of people are thrown off by that. But if it's just a normal log, by default, it's base 10. So you are allowed to fill that in if you want, you don't have to. Questions at all about the power rule, what you're allowed to do with it?
No, Mr.
Okay, so here's what I'd like you to do. I'd like you to write this problem down.
Is it a problem from our book?
No.
Oh.
Okay, I'd like you to write this problem down. This is going to be our first example. This problem, what we're going to do is, again, this is the first problem that's going to be kind of like the homework that we're doing here. This is one that I'm going to do for you, then I'm going to give you your own. But I'd like you to have this one for sure in your notes, because this will show us exactly what we're going to do with this stuff. Question?
The answer. I know.
Okay, good. So, Nicole, I want you to walk me through it.
I got 20.
So,
I got 22.
okay, you are correct. That is the answer.
You got 22, but I got 20.
Sit down.
I got 20.
Nicole, since you're the first to volunteer, did you get 20? Let's start with.
Yeah, I did.
Okay, walk me through what do you do?
Okay. 2 to the 5th is 32. So
Okay.
just replace the 32 with 2 to the 5th.
Okay, so we're replacing that log of base 2 of 32. We're replacing that with a 5, and that's to the 4th power, right? But that's a little weird, because that's not what's written here. But I agree, this is going to be something we are going to do with the 5. Now, what are we going to do with the 4, though?
Put it on front.
Yeah. You
Okay,
drop
I
it.
said put 2 to the 5th instead of the 32.
Oh, I see what you're saying. 2 to the 5th. I see what you're saying. So you want this. Log base 2, 2 to the 5th power.
Yeah, and then put the 4 in front. So
Okay, perfect. Okay, now what?
Put the 4 in front.
Put the 4 out front. Perfect,
Yeah.
I like that. So the 4 is here. Log base 2 of 2 to the 5th. Now what?
Okay, now the log 2 and the 2 cancel out, so it's just 4 times 5, which is 20.
boom, those cancel, so it's the 5 times the 4. Now, the other way you can see it, and in fact, you could have done it actually 2 different ways there, because when you were at this point, which I'm actually happy that you saw that you saw the 2 to the 5th, this 5 can drop out front as well, because it's a power on a logarithm. It's still a power rule. So it's 4 times 5 times log base 2 of 2.
Log.
And then, yeah, this part is one of the properties we talked about yesterday or the other day. That was the page 410 stuff, where that part is just a 1. So you're going to take 1 times 5 times 4, which is 20, which is the number we've been saying. Okay, are we good with the style of problem? I actually like that 2 to the 5th idea. I didn't think of that.
Like how you taught us to do it.
Yeah. So, well, I wouldn't actually do that. I would actually just change log base 2 of 32, just to say that's 5.
Wow.
Because you can just evaluate it. And then the 4 goes out front, so it's 5 times 4. That's the way I would have done it. But,
But
you
it's
know,
not
change the
5,
base.
5 to the 4th is like 5,000 something.
No, but,
No. You move this out front, and then this thing is just 5.
Yeah.
So it's 5 times 4.
Oh, you just said 5 to the 4th.
Yeah, you just put 5 times 4.
Same thing as 5 times 4.
Divided by.
So, alright, here's the problem. I'd like you to try your own. I'm going to walk around the room. I want to see if you can actually do this problem correctly using the power rule. This is the one problem. I'm going to pull it directly out of your book. Here we go.
Okay, I didn't so. Oh, I could tell you.
Oh.
Okay.
so you tell me I gotta do this in my brain or on a piece of paper?
Write it on a piece of paper.
Okay, this is my example. All I want you to do is just use the power rule and simplify this thing down until you can't go any further.
Why didn't you just put numbers in there?
I didn't want numbers. I didn't want you to evaluate it. I didn't need to calculate.
Log B?
Log base b of x to the 4th. And I want you to go however many steps you can to simplify it. It may not go very far, but I want to see what's written down is. When you have your answer, raise your hand. I want to see it.
Right
It's
here.
very easy.
One step.
Boom. Easy, yep.
It's easy.
Oh, I did it right.
You just put the 4 in front.
Those right there. Give me those ones.
Got it.
Boom. Yep.
Those are nice for
Yeah,
That
seven.
too.
Good.
Man, that's
Good. Easy peasy so far.
I like
Good.
numbers better than
Yeah.
letters.
I agree.
Make numbers.
I agree with that. Yep.
Do you agree with this?
Yes.
We're plugging numbers in.
Good.
Might have to hurry.
Good. Yes. Yes. Okay. Anything else? I already get yours. Boom. Okay. All right. Good. So, hey, are we good? Are we good with the whole power rule? Okay. We're going to come back to that later, and the idea is we're going to mix that in with the larger problems when we start mixing all of these together. So just remember, if it has a power, you're allowed to drop it out front. So you guys are right. You drop the 4 out front, and this is really the only thing you could do. Log base b of x with the 4 out front and we multiply. Okay, we're good? Jace, no half. Alright, let's go to our next rule, which is the product rule. Alright, let's clear the board here. Alright.
I was like, okay, it doesn't really matter.
Log base 2 of x times y. Let's just write that. Okay, so on this problem, I like you, when you write this down, this is giving my example of the product rule. This is the product rule. Okay. I don't have any numbers yet. We'll make up an example here in a minute that has numbers in it. So first step here is
Can I demonstrate?
no.
Yes.
No. So we're gonna separate this out,
There you go.
and we're gonna make its own logarithm. So the product rule states that if 2 items are being multiplied inside a parenthesis, you can separate them into their own logarithm
And then I'm together.
and add them together. So this is the step we talked about yesterday. It is not multiplying. In here it's multiplying, but outside, when you actually separate them, you have to add them together. Because the actual logarithm represents the powers. You'd actually add the powers because the objects have the same base, and you're trying to multiply the bases together. That's what you're actually trying to do. So when you multiply bases that have this, when you multiply bases that are the same, you actually add the powers, right? That's what you're doing. Well, this thing right here, this 2 plus 3 is what you have here. Logarithms are powers on exponents. So that signifies why it's addition. Okay, so let's do an example, like one that's in your book to show you how we can use this. So one of the examples that I saw was this. This is just one problem that was directly in the book.
Is this from our homework
I think I know.
that we will be receiving on Monday?
Should I put this in my notes?
No.
What?
Should I put this in my notes?
Yes, put it
What
in your
number
notes.
from the book
All right.
is this?
Justin.
Log 8.
Justin.
Are you,
It was near the top. It was like 1 through 2. Am I in the wrong section? Yeah, whatever. I'm doing this problem. It might be the wrong section, but it's 1, 2, 3. So that's a very top problem. Okay, all right. First step. Since these are being multiplied, you can separate them into their own logarithm.
That's number 10.
So you can separate into your own logarithm. Then, once we're separated and they're being added, now you can evaluate them separately.
Do
Nicole,
8 to the 8.
say it again?
8 to the 8.
8 times 8 is
60.
Oh, so 8 times 8 is 64. So what power are you putting on the 8 here?
64.
2.
2.
That's
What
what
power
I-
is it?
That's
What
what.
power? You're right. 8 times 8 is 64, but you're trying to, how many 8s did you have?
Yeah.
Oh!
Okay,
That's-
plus
That's on me.
Potato.
this one.
1.
1. Okay, because the power you're putting on the 8 makes this number here. So in your final answer, the answer is just 3.
12.
How'd you get 12?
12 divided. I added the 1.
I'm
All right.
sorry, how?
Flipped them.
That's what I guess. How
Put
did
them
you get
together.
why did you
Oh,
get
well,
this?
that makes sense.
Because logarithms mean powers. So that's what a logarithm stands for. So what you're trying to do is figure out what power you put on a base
Right.
that makes the number next to it. That's literally what a logarithm stands for.
So is it just for this one that you do that with?
You can do it for any problem that has numbers in there. You can always try to evaluate as you go, like what is the number that this thing represents. And that's what we're doing like the last problem.
Okay.
So, but if you can't think of it, let's say this is like a goofy number, like this was an 8, but the number inside, let's say this was like a 24. I can't put 8 to a power to make 24.
Right.
So we wouldn't be able to evaluate without a calculator. So we just leave it alone.
Okay. Okay. You're right.
All right, questions, comments?
No.
Now, I want to give you a problem and have you try it out and see what you can come up with. All right, so here's the problem I'd like you to do.
Wrestling. Say wrestling back.
All right, here's the problem I'd like you to try to simplify if you can. Log base 3 9x. Okay. I'd like you to try to expand this using the product rule and write down what your final answer is going to be. Okay, it may not go very far, but I want to know exactly what your problem's answer is. Okay, once you think you have it, I want to walk around. I want to see what you have written down. Again, everyone should have their own paper. Try to show me the work that you got. Boom.
Really?
Yep. Wait, you forgot something on the back part. Is this right? Which part? Is that right? No. Okay. No.
Is it?
That's
I think I did it wrong.
I got it.
Yeah.
Log 3x plus 1.
So far, it's good. You're not finished.
Not finished?
It's not too.
Hey, so far you are correct. You're not finished.
I don't know.
Okay, did you figure out what you need?
Mr. Ward, would you please check my answer?
Is it base 3 or just
That's what I got.
or can I change Yes,
Is this the UITP?
it is.
How's this one?
Oh, you took the
Because you're redheaded.
No. No,
It's actually this though.
You said Nicole, what is it? And I was like, what?
YTP.
Yeah, it is. Mr. Ward. His answer.
Wait, Mr. Ward, oh, it's plus 2.
No!
Wait, Mr. Ward, you didn't check mine.
Yes.
Oh, do I need to have a...
Log 3x plus 2.
Mr. Ward, I need the addition sign. Mr. Ward, do I need the addition sign?
Don't look at mine. I don't know how to do it, so I'm not gonna do it.
Mr. Ward, I fixed it. I'm right
X
now.
plus 2, but I don't know what that means, so I'm not doing it.
Do I need to check anyone else's I haven't checked yet?
Right here, Ward, Ward, right here, Ward.
Oh, I did it. Reese,
Yes.
thank you. Now I need to learn
I wanted to wait till the three minutes.
What?
See if you learn how to bring
No.
Want me to
She doesn't have a
explain?
watch on her.
Nails are black.
Hey, do I need to check anyone else's that made corrections?
I had a two in there, so
So
that was
this is when I get my nails painted. This is how. You're gonna get a black?
You're gonna get them painted graphite.
Alright. Hey, we're good? Alright. Somebody walk me through it. Nicole, you want it?
Yeah.
Okay. Walk me through it. What do you got?
Okay, log 3x, okay, no, oh, okay,
Say
yeah. Right, log 3,
Log 3,
and then write x
x,
plus
plus,
log 3,
log base 3,
3 squared.
3 squared, okay, which is 9, okay? Which I agree,
But I
that
want
is
you to write
log
3
base
squared.
3 of 3 squared. Okay, that's fine. We'll stop there. Okay, now, the thing I like about this, it doesn't matter the order she wrote it. Because these items are being added, so it doesn't matter the order you put them. So the 9 and the x, I know the 9 was out front. It doesn't matter if you put the 9 in the back or the x out in the front. It doesn't matter because when you add items, you're going to get the same answer anyway. Now, talk me through this 3 squared idea.
Yeah, cross out the 3s and then it's just 2.
Okay, good. So you know the shortcut that when you have this, you can cross these out so you're left with 2. Because the real trick is you can drop the power out front and it would be 2 times log. And then what do you have out front, Nicole?
Log 3x.
Log 3, log base 3 of x. Okay. This is the final answer. You can't go any further than that. The way I would have done this problem is a little bit different. This is correct, don't get me wrong. You're actually doing really good mathematics there. I just would have guessed what power do you put on a 3 that makes 9?
2.
That's just the answer. That's how you evaluate it on the fly. But you doing it that way is the real math, and that's good that you're actually writing that
I
down.
just like to do the
Okay, all right.
I didn't write it down, I just wrote down the answer.
Okay, so, hey, are we good with how that works? I had a lot of people that tried some weird stuff there. Just make sure that you're not losing the logs as you go. And the log will only go away when you evaluate things, like log base 3 of 9, I evaluated it. All right, we're good?
Yep.
All right, let's move on. So, quotient rule.
Like $5.
No, 5?
All right, so we're done with the product rule? Quotient rule now.
Just friends.
All right. Last example here. Last rule, I should say.
Don't tell her. I can look as far
Okay, hey. All right. Quotient rule. This is where if you had a logarithm, doesn't matter the type. Let's say it's to the 6th, well, at base 6. Let's go x divided by w. When you have a logarithm of things being divided on the inside, you're allowed to separate and make their own logarithms. So, log base 6 of x minus log base 6 of w. This is what it's equal to. Questions, comments about the whole long division, or the whole division idea? Now, the reason why this works, why it switches to subtraction, because the idea is that when you divide items that have the same bases, like I'm making up this example. Let's say that this is your problem. When you had this in algebra 2, the trick was to subtract the powers. Hey, we need to stop talking today. Because I'm kind of over this. Because we can get to homework today. I'm fine with that.
No.
So. We good to go?
Yes.
All right. So when you separate division, we get subtraction. Make sure it's subtracting the objects. Now let's do an example here. This is one example I'd like you to have in your notes before I give you your own problem. Let's go log base. Let's go log
7.
x. Let's go x over 10. Let's do that. And this is in parentheses. Okay. So we're gonna do this one before I give you your run.
Bailey Fulton, please come to the office.
Again, I'll pull one directly out of the book. Okay, and these problems are very, very similar to like 7, 8, 9 in your book. All right, so first step, we separate, we're going to subtract. So log of the top, subtracting log of the bottom. At that point, you try to see, is there any one that I can individually evaluate, and the back one is one that I can evaluate, because technically,
That's.
this is log base 10,
Cancel it.
and so the idea is that what this answer is, what number do you put on a 10 that makes 10? That would just be a 1. So this is the actual answer to that problem. Again, on a logarithm, if they don't put a base number that's like the subscript number, it's always assumed it's a 10. Alright, so I'm going to leave that on the board. I'm going to give you your own problem. Let's see how well we can do this. Let's see if we can figure out the answer for this. Again, I'm just pulling it directly out of the book to see how well you're kind of paying attention here. Okay, alright, here we go. Log base 5, 125 over y.
Not even. I just need enough.
It's
Yeah.
part of
So-
Can you do it from the top?
Well, I think it's
Is it
going back
any
to you.
What?
Is it any from the top or the bottom?
Oh, I got it.
So.
That's all I would say.
It's just what you do.
It's just.
Okay, so try to evaluate. I want to see final answer in the very end. Try to put on your paper.
5, how many times you gotta take 5 times yourself to get it,
3.
3?
No, Mr. Ward.
What change it?
Oh, wait, did I get a picture? No. Oh.
I'll see if we're answering.
Okay, I already know mine's right. Yeah. Ward, you never said anything about my picture.
Hey, Mr. Ward,
Very pretty.
is that it?
Is that an apple watching?
Yeah.
Mr. Ward, is that it?
Yes.
Yes! I got it right.
Yes.
You wanna see
Yes.
Apple Watch 3?
I don't know. I wrote this.
It's dead.
Oh, my brother cracked it yesterday.
Look at that.
This one.
My brother cracked his yesterday.
Mine never cracks because it's never on.
Yes.
What?
Sure.
Of course.
Every single day.
Yes.
Yes!
Nice.
Take a jump out. Draw Packer.
Yes. Okay. All right. It looks like everyone has it. Somebody want to walk me through it?
Yes!
Sam.
Yes!
Hey, Sam. Fire away. What do you got?
Log base 5 of 125.
Okay. Log base 3 of 125.
What? No. 5.
Go ahead.
Nice
Log
try.
base
Oh, 5. Sorry. 5. Keep going.
Minus log base 5 of y.
Okay. Good. Hold on. Okay. Hey, we need to stop chatting. Okay. Keep going.
5 to the third power is 125.
Okay. So this is just a 3.
Minus log base 5
Boom. That is your final answer. Now the reason why this thing evaluated is 3. You're trying to figure out what power you put on a 5 that makes 125. Now I know if you're doing it by like actual mathematics, like trying to do all the steps, 125 is 5 to the third power. And so technically what you're doing there is you're dropping this out front, and this idea is that this part is the number 1. So that's why it turns out to be 3. That's a lot of extra steps just to think about what do you put on the base that makes the 125. If it didn't work out nice and pretty, just leave it. Like if it doesn't evaluate, maybe this was a 4, and there's no way I'm going to make a 125 with a power. So just leave it log base 4, whatever it is. Okay. If you can evaluate like this, put the number like she did. This is the answer. That's all I want. Okay. All right. So it seems like we have a pretty good handle on the 3 properties. Okay. There wasn't too many mistakes. Simple little errors. It wasn't like major things that we were trying to figure out.
Can you check that?
So, what?
Quotient rule.
Oh, okay. So quotient rule. So let's check this off. All right. So now, one of the examples I want to do is let's do a problem where we mix all of it together. We put powers. We put things being multiplied, things being divided, all that good stuff. So here we go. So I'm gonna pull a problem from the book. Here we go. So we're mixing all 3 together just to show you how it works.
Mr. Ward, this is gonna be pretty difficult to solve.
No, you're fine. All right, here we go.
Where's my jaw at? Where's my fist at?
Okay, how's that for you?
It's not me, it's ours.
Why are you looking at me?
Quick, stop moving. Okay, ready?
Sound goes in the
Mr. Ward, this looks difficult.
The pressure.
All right. This is very similar to the middle problems in the homework, which is about problems 14 through the 17 mark. So 14 through 17, that's where the problems are. This problem in particular has every single property in it. It has product rule, it has quotient rule, it has power rule. And we're gonna do them one at a time, and so we can see how this works. So the first step that I always do is if there is a major power on the parenthesis, you're allowed to drop it out front. I don't have anything there. It's not like they're taking a big radical, we'll see that probably Monday, or they didn't have like this all to the second power. So I don't need to drop a big power out front. So what I'm allowed to do is I'm allowed to separate with division. Division means this. ln x e to the fourth, and we're going to subtract the natural log of the 3 on the bottom. Because the division is the top versus bottom. So I'm subtracting those. Does that make sense?
Yes.
Okay, now, the second thing is since these two are being multiplied together, I can separate these into their own logarithms because they're being multiplied. So this is the natural log of x plus the natural log of e to the fourth. And then out back is just still this thing. I didn't really even touch that back. So this part here is out front, and I can separate them because they're just by themselves. If I had to separate the back, you'd have to put a huge parenthesis because this negative sign would have to distribute if there's multiple items in the back. Alright, and then the last step here is the power of 4. You can drop that power of 4 out front, since there is a power on that, and then I can evaluate that problem. So natural log of x, I can drop the 4 out front, and then the one thing I can actually evaluate is this part right here, the natural log of e. So what that actually stands for is it stands for this, log base e of e. That's what it actually means. So the trick is, we've actually talked about this before, that is just a 1. Because what power do you put on e to make an e? That's 1. So it's 1 times 4 there. That's a natural log of x. This is the natural log of 3, which I don't actually know that I can evaluate that because there's not an e on it.
That was a horrible.
And so this whole answer would just be this. And again, you can rearrange, you can move things around. I can move the 4 and put that out back because maybe I want to move the natural logs closer together. It doesn't matter. You can move things around. Questions, comments about the problem that I just did there?
That's difficult.
Okay, I'm going to give you one. I want to see how well you can do one
Can
here.
you keep that one out there so we can compare?
Alright, here we go.
Thank you, Mr. Ward.
Okay, the problem I'd like you to do. Okay. Alright. Log base b x squared y over z squared.
Oh, that's goofy.
And this is on parentheses. Okay, if we get this problem right, we're done for the day.
What if we don't?
Then we're doing another one.
We're talking like entire class. No one can screw up.
No one can screw up.
We're there already.
I'm putting pressure on because I think you guys can handle it.
You think we can handle it?
Yep. Right here.
Oh, wow. This is tough.
And that bottom is a z squared.
Oh!
Justin.
I was thinking that was an X.
That was a z squared.
That makes it a lot easier.
Oh, okay, good. Good.
I wish I knew where my
Oh,
pencil
check
was
it.
at.
Actually, let me check with.
Can I move that square? What did you get?
Nicole, what did you get?
Okay, 1 second.
Mr. Ward, I think I'm
Are we
finished.
matching up?
I haven't finished writing yet.
This one.
I think I got it.
Oh, you're not finished?
What are you? Did you get a 2?
I got it. That's all I'm saying.
Dang, I'm
2 log bx
Plus log b
b of
y
y
minus 2 log b z.
I take the 2
down.
Oh yeah, look at this.
No.
I didn't even do that. Look what I did. There's a spider.
What up, today?
Someone kill this spider.
No.
Hey, Nicole.
What? So this is
What
like.
are you gonna do?
Keep
How did you? No.
Just find your twos together.
Carl, what's the message?
Did you eat it?
No.
What? Fine.
Way to go, Justin.
You didn't write it.
Yeah.
Okay.
What?
Yeah, trying to get checked.
Josh, did you get it figured out?
Mr. Ward, you really,
I already knew
you
how to
caused
do
me
it.
to
I
use
just
a lot of
wanted to
that,
make sure it was
one
right, so that I
page.
didn't get it
I
wrong.
Sorry, that was
That's
fun.
great.
We had a panic attack.
That's fine.
Aw, what are you talking about, buddy?
We moved it.
I'll walk away.
Okay.
Or. Mr. Orr.
Okay,
This is.
I'm not scared anymore. She checked her answer.
He's going with confidence. He's smiling.
Okay.
No, part above is correct.
That's not the answer though.
You know.
Oh, no. Part above
Has anyone gotten it wrong so far?
I did.
Perfect.
it. If you go with like, he did all this word and
I'm pretty sure Lucas is right.
Lars, that was pretty impressive.
that box in the middle of the page.
When?
I do know, I just,
No.
I don't remember what they called. Cause they started.
Okay, I think I got everybody's.
Yeah, you did.
Yeah, all right, good. Hey, let's talk about it. Hey, last part here. Here it is.
We all got it right.
Separating the top
No more.
versus the bottom.
No mas.
Okay, so separating top versus bottom. Then I'm going to separate the top next. Okay, so I separated top and bottom, and then the last step all you have to do is drop those powers out front. So if this power goes out front, it just becomes a 2, and the 2's gone off of it. If you drop this 2 out front, there you go, and that's what everyone had. Okay, very nicely done. All right, done for today. Very nice. That's pretty good math you guys just figured out.
Good man today.